Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll learn to interpret a speed time graph and describe the movement based on the graph, okay? So now let's refer to this graph. We'll learn a speed time graph in more detail, okay? So the y-axis is the speed, x-axis is the time. Then from P to Q, okay? We can see positive gradient, okay? So means that the object is accelerating, okay? The speed increases from u meter per second to v meter per second, okay? So the acceleration is the change in speed divided by change in time. And the area under the graph, okay, which is a trapezium, represents the distance traveled in the period of t1 seconds, okay? Then QR, okay, here zero gradient, but in this case it doesn't mean stationary, okay, because this is a speed time graph. Now it means that the object is moving with uniform speed, okay, no change of speed. So the area under the graph will be a rectangle, so it represents the distance traveled in the period of t2 minus t1 seconds, okay? Then lastly, RS, negative gradient. So here from R to S it means deceleration, okay? Negative gradient, there is no change in direction, yeah? But for a distance time graph, negative gradient means that the object is moving in opposite direction. But in this case, because it is a speed time graph, okay, so the motion of the object actually is still remains in the same direction, just that it is decelerating, okay? So the area under the graph from R to S, which is represented by region C, is the distance traveled in the period of t3 minus t2 seconds, okay? So let us go through example 14 together. The speed time graph shows the motion of Puan Salina's car for a period of 15 seconds. Okay, part A, calculate the rate of change of speed in meter per second for the first 5 seconds. So meaning we are going to find the gradient of this part of the graph, okay? So 40 minus 20 meter per second divided by 5 minus 0 second, so 4 meter per second. Part B, describe the motion of the car for the second 5 seconds. So meaning now we are going to describe the motion for this part of the graph where the object is moving with uniform speed, okay? So the car moves at a uniform speed of 40 meter per second for the period of 5 seconds. Then part C, calculate the total distance in meters traveled in the period of 15 seconds. So meaning we are going to find the area under the graph, okay, this whole thing. So again, we'll break it into a few shapes. The first shape is this trapezium, okay? Then second is a rectangle. Then lastly is a trapezium again, okay? Here is the working, okay? So the answer is 600 meters. I believe now you are more familiar in how to find the total area under the graph, okay? Example 15. Mr. Daniel Wong drives his car to a convenience store to buy newspaper. The speed time graph shows the motion of the car from his house to the road junction before reaching his destination. Part A. Describe the motion of Mr. Daniel Wong's car for the first 10 seconds. So meaning this part of the graph. So we are going to find the gradient, okay? So we know Mr. Daniel Wong's car is accelerating in the first 10 seconds. The acceleration is 25 minus 0 over 10 minus 0, which is 2.5 meter per second, okay? So the car accelerates at a rate of 2.5 meter per second for the first 10 seconds. Then part B, what happens to the motion of Mr. Daniel Wong's car from the 10th second till the 20th second? So here, zero gradient, okay? So it means the car is moving at a uniform speed of 25 meter per second from the 10th second till the 20th second. Then part C, calculate the rate of change of speed in meter per second for the last 5 seconds, meaning here, okay? So the object is decelerating, so in this case there will be a negative sign. Okay, so let's see. The gradient is 0 minus 25 meter per second over 35 minus 20 seconds, so negative 5 over 3 meter per second. Okay, so we know the car is decelerating. Then part D, calculate the distance in meters traveled during deceleration. So what we are going to do is we'll find the area under the graph for this part, which is a triangle. Okay, half times base is 15, height is 25. So the answer is 187.5 meters. Okay, describe the motion of the car. So the car travels for 187.5 meter in 15 seconds with a deceleration of 5.3 meter per second. Okay, so now we have reached the homework. Go back, you guys will complete this self-practice 7.2C. Okay, so if you guys are struggling, you are having a lot of difficulty, a lot of challenges in completing all this homework, I have prepared an online course. Okay, so it is a step-by-step guideline in helping you guys to complete all this homework in the textbook, including the comprehensive practice at the back of each chapter. Okay, so we have learned all this knowledge. We'll learn how to solve problems involving speed-time graph in the upcoming video. Okay, so do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos. Okay, I'll see you in the next video. Bye bye.